Okay, ladies and gentlemen, we're going to start talking about degrees and radians. With degrees and radians, what we're going to need to first deal with is the fact that on an xy axis, the positive x-axis is at 0 degrees. So if we set one side of our angle right over here on 0 degrees, that would of course be the initial side. We can then make an angle with that initial side. So here we go. We got about 5 degrees, got about 20 degrees, got about 45 degrees, 75 degrees, 90 degrees, 110, 120, 150, 180. Then you got 200, 210, 230, 270. Then you got 300, 310, 340, 360, 360. Now, the thing is, you could also keep going. You have 400. Then you start talking about 450. Then you start talking about you get all the way around, you get 720. Go around again, you get 1080. Okay, so you can go around forever and ever and ever you wish. Standard position is from initial moving counterclockwise to your terminal angle. In this case, let's just throw it out here at 45 degrees. Now, initial side, terminal side. Now, we could go the other way, by the way. Instead of going 45 degrees, I could go 45, swing around, and now I'm at 405. So if I have 45, 405, those would both be in the same spot because you're just going around to get to it. Those are called coterminal. Those are coterminal angles. By the way, we could also go the other way. Instead of going positive, let's go negative. Go all the way around until I get to negative 315. So go this way around to get to it, negative 315. That's also coterminal. Co meaning with. They have the same ending point. With the same ending point. So, coterminal. So you have all sorts of degrees. A lot of times they can be listed as angle plus 360K. Where K is a counter. So if I have 45 plus 360, no times. 45 plus 360, one time. 45 plus 360, two times. Okay, and just over and over and over. And so you get 45, 405, 765, and on and on and on. Okay, now, that's degrees. We should know degrees pretty well. And with that, we can memorize all the various degrees all the way around. But we don't really want to just sit and memorize a bunch of degrees, so let's talk about the next phase of what we're going to talk about. We want to start talking about the idea of radians. So a radian is a concept that we're going to come back to and that we want to base off the following. If I have a circle, and that circle has a radius of 1 unit, the distance around that circle is its circumference. Well, we know from 4th grade math that circumference equals 2 pi r. Well, if our radius is 1, circumference equals 2 pi 1, also known as 2 pi. So that's it. It's going to be 2 pi units. Now, I don't know what the units are, so we just put units. Now, if I wanted only to go halfway around a circle whose circumference is 2 pi, well, half of a circumference is going to be 2 pi divided by 2 and or pi. If I wanted only to go a quarter of the way around, so when 1/2, 1/4, okay, I would say 1/4 of the circumference equals 2 pi over 4, which is pi over 2. Now, before long, you should start to see some connections. All the way around a circle is 360 degrees. Halfway around a circle goes together with 180 degrees. A quarter of the way around a circle goes with 90 degrees. So we can begin connecting the distance around a circle. So this length here around the outside with the idea of what are we doing inside the angle. So degrees deal with the angle, radians deal with the length of the distance around. Now, what we're going to call that is radians are a measure of arc length. Radians are a measure of arc length. And as you can see with a radius of 1, they become very basic. Well, if I have a radius of 4, all I have to do is take whatever my distance around is, my radians. Let's say I have 2 pi radians. But if this new circle here has a radius of 4, then the distance all the way around is going to be 2 pi, which is all the way around, times a radius of 4, because 2 pi r is 2 pi times 4, and the answer there would be 8 pi. That is the units. Now, in this case, radians don't have specific units. But if this is 4 feet, then it's going to be 8 pi feet, or approximately 25 feet. That would be the distance around. So that's what radians are, and that's what radians are used for. Now, we need to be able to convert back and forth between them. So, if I want to go back and forth between radians and degrees, that's not too challenging. If I have 45 degrees, and I know that a full circle is 2 pi, or a full circle is 360 degrees, I can use that as a conversion. I simply use a unit conversion. So if I have degrees on top and I want radians left over, I'm going to put radians on top, degrees on the bottom. The degrees cancel out, giving me 90 pi over 360. That reduces to 1/4. So the answer here is pi over 4. So 45 degrees goes with pi over 4. Your first homework problem is the following. Convert 30 degrees to radians. Convert 315 degrees to radians. That's the first thing you need to do for homework. Number 1, number 2. Now, let's go the other way. Let's go from pi over 2 radians back to degrees. To do that, I'm going to multiply, and I want to get rid of radians. So radians, instead of 2 pi over 360, it's going to be 360 over 2 pi, because I want the degrees left on top. I want the radians to cancel out. Another big hint is the pi's are going to cancel out. So I end up with 360 divided by 4, which is 90 degrees. So you have a couple more homework problems. Pi over 3 needs to go to degrees. So pi over 3 radians needs to go to degrees. Number 4, 5 pi over 6 radians needs to go to degrees. So there you go, a couple more. So, for those of you that are playing along at home, in short, we're going to either use 2 pi over 360 if I want radians left over, or I'm going to use 360 over 2 pi if I want degrees left over. Those are two giant things that you must know. Now, some of you say, well, I can make it even easier than that. Can't we just turn those into pi over 180 and 180 over pi? The answer is, of course, yes. You could divide 2 and divide 2. Works out nicely. I tend to use these two over here, but this is where they come from. Now, that is going from radians to degrees, degrees to radians. That's not the only way we can do it. We also have this thing among degrees by themselves. Not everything ends exactly at 45 degrees. Maybe it's 45.4 degrees, 45.4 degrees. Well, I could give a decimal degree, and that's what this is called, decimal degree. But there's another way to write these, and that is by writing them as degrees, and then minutes, and then seconds. Degrees, minutes, and seconds. If I take a degree and I chop it into 60 chunks, then I'm going to get 1 minute. So 60 minutes equals 1 degree. If I take 1 minute and I chop it into 60 chunks, I get seconds. So I have degrees, minutes, seconds. There are 60 seconds in a minute, 60 minutes in a degree. So if I have this, 45.4, what I'm going to do is I'm going to say, how many degrees do I have? Well, my degrees are going to be 45 regardless. So I have 45 degrees. Now that leaves me with 0.4. So to change 0.4 into minutes, I'm going to say there are 60 minutes in 1 degree. Well, the degrees cancel out. I take 0.4 times 60. 0.4 times 60. Answer is 24. Now for minutes, we put either MIN or we could just put an apostrophe. Now you'll notice with my 24 there is nothing left over. So I have no seconds left on the clock. So 45.4 degrees turns into 45 degrees, 24 minutes, and 0 seconds. That is my answer. Now, let's do another one. If I have 32.1753 degrees, I want to change that to degrees, minutes, seconds. Well, that's from decimal degrees. Now I want to go 32 degrees, followed by, I'm going to take 0.1753. That's in degrees. I need to multiply it by 60 minutes over 1 degree. Cancel, cancel. I come up with 0.1753 times 60. And that gives me 10.518. 10.518. Now my problem is that's going to be 10 whole minutes, but I got this 0.518. So to find the seconds, I'm going to take 0.518, multiply it by 60, because there's 60 seconds in 1 minute. The minutes, because it's now in minutes, cancel out. And so I take that, 0.518 times 60. Answer is 31.08. Now the problem is I'm down to the smallest level I have, which is seconds. So I'm just going to use this to round it. 31 is going to stay 31. If it were 31.78, then round up to 32. That's going from decimal degrees to degrees, minutes, seconds. Now let's go the other way very quickly. If I have degrees, minutes, seconds, I have 17 degrees, 14 minutes, and 13 seconds. That means I'm going to say 17 degrees for my decimal, point, and if I have 14 minutes, that's the same thing as saying 14 over 60 plus 13, but 13 is seconds. How many seconds are there in a degree? Well, there's 60 seconds in a minute, 60 minutes in a degree, so that's going to be 13 over 3,600. If I take my calculator and I take 14 divided by 60 plus 13 divided by 3,600, that gives me a decimal of 0.23694. 23694 repeating. I have now gone from degrees, minutes, seconds to decimal degrees. Your problem number 5 for homework is to go from 17.321 degrees to degrees, minutes, seconds. Number 6, 314.2 degrees to degrees, minutes, seconds. Finally, 7, I want 128 degrees, 2 minutes, and 15 seconds to decimal degrees. And 8, we need 214 degrees, 3 minutes, 13 seconds to decimal degrees. All right, write them down, turn them in.